Okay. So tell us your name and tell us about the project.
I'm Sir Colton Dodson, colleague of Sir Arthur Eddington. We made a trip to an island of Principe in order to view the eclipse that took place on May 29th, 1919. During this time, we observed how light from the Hyades star cluster passed through the sun's gravity field. We knew that light from the Hyades cluster would have to pass through the sun's gravitational field during the eclipse. We took and compared pictures of the eclipse versus pictures of the star normally. This was to see if the sun's gravitational field would influence the light passing from the Hyades star cluster. The solar eclipse allowed for us to measure the stars with gravity-shifted positions. We measured the positions of the stars normally, then we compared that to the position through the sun's gravitational lens.
So, what were you guys trying to do or find during this experiment?
We were trying to see if the gravity from our sun would have an effect on the light behind it, passing towards us. By noting the change caused by the gravitational field, we were able to prove that Einstein's general theory of relativity was accurate based on if gravitational fields would cause warps in space-time. Seeing the difference from the position of the stars normally, then comparing it to the positions during the eclipse. The pictures of the stars from a regular night compared to the eclipse pictured had gaps, which was caused by the light bending, which was caused by the gravity from the sun. This difference proved that gravity fields affect light travel, as the light that we observed warped slightly around the sun, which would later come to be known as gravitational lensing. The warp proved that Albert Einstein was correct in his theory of relativity.
Where did the project or experiment occur?
We actually had two groups during the experiment, as we were worried that bad weather or that clouds would keep us from being able to see the eclipse. We had one group, the group that I was with, on an island of Principe, which is a small island laying off the coast of Africa in the Gulf of Guinea, where we took many pictures of the eclipse, carrying in telescopes, cameras, and much more equipment. And the other group was sent to Sobral, Brazil, in hope that they would have agreeable weather, even if we didn't.
So, what other significant events were happening around the world at this time?
Well, during this time, World War I had just ended. Woodrow Wilson had won a Nobel Peace Prize, and the League of Nations was created. Also, the 19th Amendment was passed during that time.
Who else besides yourself was involved in the project?
Well, before the experiment, William de Sitter sent me numerous letters and papers detailing Einstein's new general theory of relativity. Sir Frank Watson Dyson, Astronomer Royal of Britain, had proposed the expeditions to Brazil and Principe to determine if Newton or Einstein was the more accurate about light bending in a gravitational field. This expedition was backed by the Royal Astronomical Society.
What was your role in this project?
My role in the project was to travel to Principe, map out the stars' locations before the eclipse, and then measure the space-time deflection in the starlight during the eclipse. I was one of the few people in the world that could perform these calculations.
What impact did your project have on the physics community?
The main impact of this experiment was that it proved that Albert Einstein's general theory of relativity was correct. This was a huge shift from Newton's theory to Einstein's theory of relativity, which predicted half of the deflection. Many scientists favored Newton's theory over Einstein's due to the fact that Newton was more credible at the time, and that there was a general mistrust of German scientists due to the fact that World War I had just ended. This gave us a larger understanding of how light traveled and the state of relativity. This not only gave more credibility to his work, but it also made him a more prominent figure in the scientific community.
What were some of the issues or problems that you came across in your experiment?
Well, there were two really big problems that arose. The first problem was that Sir Arthur Eddington was called to serve in the military before the expedition began. He actually had to appeal to multiple courts, telling them about the importance of his research before he could go. During the expedition, it had rained for 2 weeks prior to and during the day of the eclipse. This was one of the reasons we sent 2 groups to 2 different locations. Also, many of us were worried that we weren't going to be able to see it at all with the weather. Eventually, a few minutes before the eclipse, the clouds dispersed and we were able to conduct our experiment. The group in Brazil also had trouble with the jungle heat. The high temperatures caused the metal to warp in their larger telescope, but luckily they had smaller telescopes on hand that remained relatively unaffected.
All right.
How long is that? 5:20.